Hello learners, my name is Ayushi Mittal and today we are back with other question named Cherry Pickup Part 2. Okay, so let's see what the question says. The question says, given our rows into columns, matrix grid representing a field of cherries, each cell in grid represents the number of cherries that you can collect. You have two robots that can collect cherries for you. Robot number 1 is located at top left corner here, and robot 2 is located at top right corner. It is in top left and this is in top right. Return the maximum number of cherries collection using both the robots following the rules below. Okay, so now what it says, from a cell I comma j, let's say we are on I comma j, right? Robots can move to cell I plus j minus 1, I plus 1 comma j minus 1, I plus 1 comma j, I plus 1 comma j, and I plus 1 comma j, I plus 1 comma j plus 1. Okay, so robots can go either here or here or here. In this, if you want to see, this robot can go either. Okay, if suppose robot is here, then robot can either go here or here or here. Okay, so let's see the second point. When any robot is passing through a cell, it picks it up all cherries and the cell becomes empty, that is 0. Like if this robot comes to this portion, then all the cherries on this portion is given to robot 1, and now robot 2 will, if robot 2 will come to this position, robot 2 will get 0 number of cherries. Okay. Third point says, when both robots stay on the same cell, only one of them takes the cherry. Obviously, because for the next robot, the cherry number of cherries will be 0. Both robots can not move outside of the grid at any moment. Like this robot cannot go here, right? Or this robot cannot go over here. Okay, very fine. Both robots each should reach the bottom row in the grid. They should reach to the bottom row of the grid. Okay, so we have to tell what is the maximum number of cherries these two robots will take. So clearly this question is of DP. Basically in DP we used to have I comma I and j, but because there are two robots or two people who are taking, so we'll be having j1 and j2. j1 is for column of root robot 1 and for j2 is for robot 2. Okay, so here the problem is, in DP generally the question says that it will end to some column, like the problem will end to this particular cell or this particular cell or any particular cell, but here it is not given, and we don't know that which row on which column the robots will get the maximum number of cherries. Maximum number, we don't know that in which particular column or in which particular cell the robots will get the maximum number of cherries. Now let's try to understand this with the help of code. So here is the code for you guys. let's see let's understand each step in the code. Okay, so first we have seen number of n is equals to number of rows we have, and m is number of columns we have. Here we can make dp because for memorization we are making a table of 3D matrix. We can make a 3D matrix dp because in further we are going to use recursion. Okay, uh, so why we want memorization? Because if we will not use memorization or matrix for memorization, we have to compute that particular cell again and again. Okay, so we can't do that. So for memorization we can we are doing this memorization in the form of matrix. Why? Because to store a particular value in a particular cell so that we don't have to repeat that particular thing again. Okay, so let's see what the function says, because this is the most important. Okay, so let's see from here. First of all, int cherries equals to, okay, now we have two columns. This column is for robot 1 and this column is for robot 2. Okay, so what this particular line says, that if both the robots are, suppose if column 1 is equals to column 2, that both the robots are on same particular column, then we need to, then it will be calculated only for C1 and it only be calculated once, that is grid R plus C1, and we will not calculate it again. So we can put 0 over here, as we have rule also over here that when both the robots stays on the same cell, only one of them takes the cherries. Okay, so because both of them are on, suppose there is a column 5, suppose I comma j, and j is same for both of them. If both of them is same, then we don't have to repeat it. Okay, so we are just calculating for one, and if both of them is, if both of them is equal, then we will if C1 is equals to C2, our number of cherries will be equal to grid R C1. Okay, if not, if these are different, then it makes sense that we calculate for R C1 plus grid R of C2, like both the cells of the robots. Okay, both the robots cells. Okay, so we come to know what a number of, this says number of cherries in that particular row. Okay, now we are going to calculate result or number of cherries for next row. We have initialized it with 0. Okay, now we'll move further and we'll see the maximum number of cherries in next row with the help of this loop. Now how will this help us? As we know, either we can go to I plus 1 comma j minus 1 I plus 1 comma j, or I plus 1 comma j plus 1, right? So this will help us in the movement. This particular loop will help us in the movement of this ones. How? Let's see. I minus 1, which is minus 1 to 2, that is it will go up to I equal to 1, right? So it is going to I equal to 1. Okay, why we are doing it nested loops? Why? Because we want to check for each and every pair. Like let's understand over here. Suppose we have big grid. Okay, and let's say robot 1 is on this place and robot 2 is on this place. Okay, so the positions R1 can go is here, 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 and R2 can go here, here, and here. So basically, if we see, we have 9 pairs. Okay, how? This one and these 3 for this one, 3 for this one, and 3 for this one. So this comes out to be 9. So we are trying to compute for each and every particular pair, each and every particular cell in which they can go. Okay, so this is the way we do this particular thing. Okay, let's see completely what it says. For int I is equals to minus 1, I less than 2, that is, it will be computed for minus 1, 0, and 1. Okay, and for int j is equals to minus 1, j less than 2, j plus plus. Okay, and C1 is new column for robot 1, and NC2 is new column for robot 2. As I said, each and every robot 1's cell will be computed for each and every column of robot 2. Okay, now we have condition that if NC1 is in between 0 to columns length, okay, and NC2 is also in between them only. Let's see, if the robot's column is greater than or equal to 0 and NC1 less than M. What is M over here? M is number of columns. Okay. And same we have checked for NC2 over here. Okay. Now we have seen that result from next row should be maximum, like we are calculating maximum of either it is the only thing which is maximum, or we are recursively seeing that if we have its maximum or not. Let's see this one also. Grid is in given question. N is number of rows, M is number of columns, R plus 1 is on next step, NC1 is the new position of robot 1, NC2 is new position of robot 2, and TP, this is where we are storing the answers. Okay, so after calculating this result from next row, we having the answer for particular robot 1's column, robot 2's column, and a particular row. We have number of cherries over that particular column, over that particular row, and we have results from next row also. Okay, and we have summed up, and now we have answer for that particular column. Okay, so with this we'll get the answer for 0th row, and robot 1 on 0th position, and robot 2 on m-1 position. So that's it for today. Hope you liked it and get the intuition behind it, and get to know how we can do this DP problem. It's very nice problem, and hope you enjoyed it. So thank you so much for watching. Be safe and keep coding. Bye.